Hello, good evening all. Am I audible?
Yes, ma'am.
All right, so today is week 8. So how many of you have watched week 8? Can you raise your hands? Nobody has watched? No? Okay. Week 8 is a part of quiz 2, right? Week 8 is part of quiz 2. Start watching the lectures because there are a lot of topics in there. Yeah, I'll share my screen. Is my screen visible to all of you?
Yes, ma'am.
Okay. Okay, so first of all, what are the topics that you're going to see in week 8? So one
Conditional
is,
probability.
yeah, you will see conditional probability.
Marginal probability.
Yes. You will see marginal.
Hello, ma'am.
Yes.
Ma'am, how to go through extra activity 1 and 2?
How to go through extra activity. Okay. So, okay, let me take that first. So in extra activity, you must have also, you must be given also one video. So the
Ma'am, but I don't have a student ID. I have
uh,
to go through the particular Gmail ID and attend all lectures, and login ID is also my Gmail ID.
why don't
Then
you have the student ID? You're a regular student, right? Term student.
yes,
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 ma'am.
ma'am, I am regular
They
student, but
not
in a
professor.
particular video, the professor asked to log into student ID.
No, no, I'm asking why don't you have student ID?
Because we are qualified students and we will get our ID after the end term exams.
Oh, only after the interim exam you get. Oh, okay, okay.
Then we, ma'am, extra activities due date is November, and how to go through these extra activity without a
Okay.
student ID.
Uh, okay. So, but you know what to do in extra activity, right? You have to prepare one site, Google website for your course, and then that is, I think, your first activity. Then the second activity is depending on your interest on any topic, whether it can be food, it can be cricket, football, Bollywood, food, music, movies, anything you like. Pick a topic. You have to pick up a data set, and the information is given to you that the data set should have this number of column, this these many number of rows. All that is given to you. At least these many number of columns and rows the data set should have. And from there, you need to identify your categories, your variables. You need to identify. You need to identify the scales of measurement. Everything, all the information is given to you. What exactly you have to do. The
And
sample
also draw
examples.
the pie chart or bar chart.
What? What?
And in the activity also we can draw the bar chart and pie chart.
Yes, yes, that is also given. So there's a sample example that is given to you. Maybe I'll show on the screen. Just hold on, I will stop sharing this. Let me present.
But ma'am, how to get review?
So review will be randomized. I mean, it's a peer review basically. So your peers will give you a review. So it will be a randomly assigned your activity to some three people, or randomly assigned to three people, and they will give you the review.
Ma'am, but we published our extra activity,
Mhm.
particular domain IITM.
Hmm.
But
But
how?
you are saying you don't have the IITM ID, right? Is
Yeah,
that
ma'am. Yeah,
IITM?
yeah, ma'am.
You don't have the ID. Okay, so let me check on that. Maybe we'll change something, and we'll inform you on that.
Okay, ma'am.
Ma'am, so can you increase the due date for that
Yes, ma'am,
extra
because
activity?
I have not.
Yeah, yeah. I will just check on that, and we'll see what can be done. Just give me a minute.
हेलो मैम,
Yes. Hmm.
क्या मैम पॉसिबल है कि हम अपनी जीमेल आईडी से ही सारा पब्लिश कर दें?
नहीं, अभी अभी डोंट डू एनीथिंग। हम लोग बता देंगे क्या करना है।
ठीक।
Okay. Let me just share this extra activity. So for now, what is the deadline for you?
Ma'am, 21.
Oh, it's
21st November.
close. Okay, okay. For both the activities, it for both activity 1 and activity 2. Activity 1 is 21st November.
Yes, ma'am, both.
Activity 2, I see 21st November. Okay, okay. Okay, so let me check on that, and then we can get back to you on this. Yeah, accordingly we'll have to, because otherwise, let's see. By tomorrow we'll let you know. We'll like send you an email, like what exactly you have to do. Okay.
Ma'am, and if possible, ma'am, please increase the due date for the extra activity.
Yeah. Okay. Let us see. Hmm.
Excuse me, ma'am.
Yes.
Ma'am, can I do this class? Because ma'am, today whatever link was sent to me for the statistics one, so that link was not working. So when I was clicking that link, it was showing an error message. So I clicked the previous link and joined this class. So can I do this?
Sorry, can you repeat?
Ma'am, whatever link was sent to me for today's statistics class, so
Hmm.
ma'am, through that link I was unable to join. When I was clicking that link, it was showing an error message to me. So ma'am, for that reason I clicked the previous message, previous link, and then joined in this class. So ma'am, can I join this class?
You are from statistics one, right?
Yes, ma'am, and foundation level, and my quiz one was at 29th of October.
Yeah, you can.
Okay, ma'am, thank you.
Yeah. Okay, I see one message from Vishnu. Give holiday. You already have a holiday. I mean, since this is I think it's coming on Sunday, no? Sunday or Monday maybe. So that is not up to you. So maybe you can finish your assignments before that. Okay, let's not delay more. Let's start now. So week 8, you are going to see conditional probability, marginal probability, joint probability. You are going to see independence of events. You are going to see total probability, law of total probability. And then you have Bayes theorem. So first we'll start with, okay, before this we also have contingency table that we had seen earlier. So where did you see contingency table before? Can someone tell me?
Week 4. In week 4.
Week 4, ma'am.
Yeah, no, for what? Yeah. For week 4, but for what?
When the variables are
categorical
categorical, two variables are categorical. Yeah.
Yeah, so for one categorical, one numerical variable, when you have, we used to do contingency table. Right?
No, ma'am. Both variables should be categorical variable.
Sorry. Yeah, both variables should be categorical. And when you have one categorical, one numerical, in that case, you have biserial correlation.
Yeah, correct.
Yeah. All right. So none of you have watched the lectures?
No, ma'am.
See, before
No,
coming,
ma'am.
you should
Actually, ma'am,
watch the lectures and come.
we have
Ma'am, what's the lecture?
You have watched? Okay. Right. So let's create one contingency table. So let's take the same example that we had for owning a smartphone and gender, right? Okay. This is, let's say, ownership. And this is, let's say, gender. Okay. So ownership, when I'm writing, so either the person owns a phone or the person does not own a phone, right? So no, yes. Gender, it's female and male. Then you had the row total, column total. So this is row total. This is column total. All right. So first, let's start with the marginal probability. So see, you were given the numbers such that, let's say there are 10 female who does not own a phone. There are 34 females who own a phone, 14 male who do not own a phone, and 42 male who owns a phone. This is what that was given to you. Now, whatever you obtain at the margin of the rows and column. So if this is the first row, let's say, this is the second row. So at the margin, whatever comes as, like you add these, right? So suppose you want to know how many females are there, right? So that is just 44. Then if you add the entries in the second row, it gives you number of males. So this is how much? This is 56. Similarly, you do the column total. So this also, so these are called the margins, right? So whatever you obtain at the margins, they are called, and we'll see why they are called the marginal probability. Like, how do you find the marginal probability? So column total is 2476 and total was coming to be 100. So this is a contingency table that you have seen. Now, what you do is you divide each of these entries by by 100. Okay. So if you divide each of the entries by 100, that will give you probability, right? Because total you have 100 people, right? So you divide everything by 100. So if you divide everything by 100, this will add up to probability. You see, probability always add up to 1, right? So this is 1. So whatever probabilities you obtain at the margins, so at the margins as in margins of row and the margins of column, they are called the marginal probabilities. So this is like, so from the questions that can be asked is, let's say, what is the probability of a female? So what can you say from here? What is the probability of female? How many females are there?
44
Uh,
by 44 by 10.
44 by 100.
44 by 10, so 0.44. What is the probability that a person do not own a phone?
And
0.2.
mute
Male or
everyone.
Not own a phone. This is 24, right? So 0.24. So you see all these 4 numbers, they are like, they're at the margins and they are called the marginal probabilities. So if you look at this number, this is nothing but probability of female. This number is probability of male. This number is probability that a person do not own a phone. This number gives you probability that a person owns a phone. So things like this you will see, like marginal probability. Okay, well, first let's see what is joint probability also. Then I will go further. So, and whatever number you see, these numbers, right? I mean, these 4 numbers, they are called the joint probability. So joint as in like, suppose if I take this number, okay, this was done, right? So let's say I take this number, the first row, first column. So this is given as 0.10. And what does this number shows? So this is the probability that the person you pick is a female and they do not own a smartphone, right? So you write it like probability that the person is a female and do not own a phone. So you see, this is more like you have two events here, right? You have two events. One event is the person being a female, and the second event is the person do not own a phone. And you are taking the intersection of it, right? This is nothing but the intersection. So this and acts like an intersection. So probability of the person being a female and do not own a phone is nothing but 10 by 100, right? Now, if I look at first row and second column, this is given as 0.34. What does it mean? It means 0.34 is the probability that the person you have picked is going to be a female and they own a mobile smartphone, right? So this is how you interpret these numbers. So joint probabilities are done. Then you have marginal probabilities are also done. Then you have conditional probability. How do you find the conditional probability? So conditional probability is something like you have given some condition and now you are restricting your sample space in that case. For example, let's say I'm restricting that I'm only going to talk about the female buyers. Okay. So if I'm just restricting my sample space to female, then in that case, I can ask what is the probability that a female owns a mobile phone, right? This is something that can be asked. So what is the probability that a female owns a smartphone?
34 divided by 44.
0.34.
0.34, right? So this is this number.
So, ma'am, what is the difference between conditional and joint probability?
Yeah, I'll come to that. Okay. See, let me write it here. How do I this table belong? Let me make this table again. So how? You have the gender, commercial. Female, male. The numbers were 10 by 44, 14 by 56, 34 by 44, 42 by 56. There you have row total. Column total. This is 24 by 100. 76 by 100. This is 44 by 100. This was the table we had. So the first question that we're asking here is, find the probability that someone do not own a phone given that it's a female.
Ten by 44.
What? 10 by?
44.
10 by 44.
10 by 100, ma'am, I think.
10 by 100? Why?
By 44.
44. Ah.
Ma'am, 10 by 44 only.
10 by 44 only, right? Okay, I think I have directly written here. Okay. See, the question was, what is the probability that, given that the buyer is a female, the probability that the person do not own a phone. Okay. So you need to look at not total number of females. So how many females do you have in total? 44. And out of 44, how many do not own a phone? So that is 10. That is 10 by 44. So previously what we were doing is, we were finding what is the probability of person being a female and not owning a smartphone. But now we are restricting our sample space to just female, right? So when you're restricting the sample space to female, I mean, now in your sample space, you only have 44 people. So that is a difference here. So now since you have only 44 people, out of 44 people, you know, 10 people do not own a phone. So this will give you the probability, this condition probability. So in general, so as I said, these are two events. So let's say this is event E and this is event F. Okay. And probability, generally conditional probability, how we denote it as, you write E intersection F. So here, the event E is the person do not own a smartphone. Event F is the person being a female. And this is given by the formula that probability of E intersection F divided by probability of F. So if you look at this formula, can you tell me from there what is probability E intersection F?
10.
E intersection F mean, first of all, what do you mean by E intersection F?
The females who do not own a smartphone.
Females who do not own a smartphone. That was 10 by 100 probability.
Yes.
And what is probability of F?
44 by 100.
44 by 100, right? So you see both gives the same answer. Okay. Okay, now if I ask, what is the probability that the person is a female, given that she do not own a mobile phone? Do not own a mobile phone. Can someone tell me this?
Ma'am.
The person, what is the probability that the person is a female, given that she do not own a
Ma'am, there is some disturbance.
Your voice is breaking, ma'am.
I think some okay. No, what I'm saying is find the probability that the person is a female, given that they do not own a mobile phone.
10 upon 24.
10 upon
Ma'am,
44.
44 upon 100.
Okay, I get multiple answers. 44 divided by 100.
10 upon 24.
10 upon 24, ma'am.
10 upon 24.
Okay, so most of you are agreeing to 10 upon 24, right? Yes. So this is because now we have to restrict our sample space to this column. And how many people do not own a mobile phone? It's 24. And out of those 24, 10 are female. So the probability should be 10 upon 24. So this is the right answer. Okay.
Ma'am, can you explain that intersection one question, the last question?
Intersection?
That the last question,
Actually,
do not.
we not get this point.
You do not get this point. Okay. So see,
Yeah.
in this question,
No, ma'am.
The
Previous
last
question.
question, yeah, the do not own a phone and female.
oh, you do not understand this one.
Yeah, ma'am.
No.
Okay.
This one.
So the question here is, what is the probability that the person, see, you see this sign, okay, this straight line, it says whatever is after this line, okay, it means that is given to you, this thing is given to you. So given that the buyers are female, now you have to find the probability that the buyer do not own a smartphone. Okay, so female is given. So now, since you know, now you don't have to look at all the 100 people. Okay, you can just look at 44 female, and from there you can find the probabilities, right? So that would be just 10 upon 44, because out of these 44 female, you know that 10 female do not own a smartphone. The probability will be 10 upon 44.
Actually, then, ma'am, there is one question. What is mean of second line, which is just down from it?
Which second line?
Yeah, ma'am,
Just down from it.
Intersection point.
This one?
Probability of, yeah, ma'am. Probability of.
This is okay. So see, do not own a phone is one event, right?
Yeah.
Female is one event. So I'm just denoting it as E intersection E given F.
Okay.
This is how we read it. Probability do not own a smartphone. Given this line, you can read it as given. This information is given to you. So now I have written these event as E and F. The probability of E given F, this is the formula for finding the conditional probability.
Okay.
Ma'am, how E intersection F is 10 by 100?
Because now you're talking about E intersection F, and E intersection F is nothing but the joint probability, right? I mean, this is what E intersection is: probability that the person do not own a smartphone and the person is a female. So this table if you look at this table, this is what this number
Your voice is breaking, ma'am.
is it for everyone or just for few people?
No, ma'am,
Yes,
the
ma'am.
voice
voice
is
Your
is
voice
absolutely
is
clear, ma'am.
breaking.
Your voice is breaking.
Oh, okay. Let me see. Let me check.
Ma'am, now it's clear.
Now it's clear.
Yes, ma'am.
Okay, I don't know. All right. So what I was saying is, see, their probability E intersection F is what? This is probability that the person do not own a smartphone and the person is a female. So here, this is, we are not restricting the sample space to female or male. We are saying now your sample space is full 100 people. So out of those 100 people, now you have to look at the number which satisfy both this condition. And both this condition are that the one condition is person should be female, one condition is the person do not own a smartphone. And that number is 10. So this turns out to be 10 by 100. And probability of F is what? Probability of a female. And that is 44 by 100. Right?
Okay, ma'am. Clear.
Okay.
Okay.
All right. So this was all about contingency table. Now we will look at some of the examples. Just see one very basic example. Suppose you are rolling a fair die twice. Rolling a fair die twice. Okay. The question is,
Ma'am,
yeah.
ma'am, I have a small doubt.
Hmm.
Ma'am, what is identical?
What is identical?
Yes, ma'am.
Identical means everything is same. I mean, let's say if I'm saying
Take an example
identical,
of 6 ring.
Example of
6 ring. Also there, na?
what?
6 ring.
6 rings.
Yes, ma'am.
Identical means everything are same. If I'm saying 6 rings are identical, it means all the rings are same. I mean, they all look in all the way, all the 6 rings you're talking about are same.
Okay, ma'am,
There
got
is
it.
no way to distinguish that one is different from other.
Okay, ma'am.
All right. Rolling of fair die twice. Yeah. So the question over here is, suppose one of the die is, or one of the die lands on number 1. Now, what is the probability that the sum of the two numbers will be, let's say, 4? This is given to us, okay? Given that. So when you roll a fair die twice, how many sample space do you get? What is the cardinality of the sample space?
36.
36. Yeah. Now what we are saying is, it is given that one of the die lands on number 1. So you already know that on the first roll, the die has landed on number 1. Now you need to find the probability that the sum of these two dice, right, that should give you the sum should be 4.
Ma'am, 1/6.
1 by 2.
1 by 18.
Is it 1 by 2?
1
1
by
by
30.
18.
Okay, Lord. 1 by 18. Any other answers?
1 by
1 by 3.
1 by 36.
1 by
1 by 3.
1 by
Ma'am,
3.
1/6.
1 by 2. 1 by 6.
1 by 2.
1 by 36.
1 by 36. I got 5 different answers. Which one is correct? Repeat.
1 by 36.
Did not understand. Okay. Okay. So for the people who do not understand the question, I will repeat it once. So the question is, you have given 2 fair die. Okay. Now you need to find the probability that when you roll these 2 dice, the sum of the 2 numbers should be 4. Okay. But there is an additional information given to you. It is given that one of the land you have already, one of the die you have already observed that it lands on the number 1. So this is already fixed. So one number is already fixed. So now you have to find the probability that the sum of the number will be 4. Sum of the 2 numbers will be 4.
And 1 by 36.
1 by
1 by
36, ma'am.
36
It will
should
be
be
1 by
answered.
6. It
1
will
by
be 1 by
36.
6.
1 by 36.
So a lot of people say
1 by 36.
1 by 6. 1 by 6.
okay. I will ask. So for the people who are saying it is 1 by 36, can you tell me what's the reason? Why do you think the answer should be 1 by 36?
Because in the other die there is a possibility of 3. So then only it will become, sum will be add up to 4.
Okay. So you're saying for this to happen, for the sum to be 4, it should be, this number should be 3. So you have just one
Yes, ma'am.
possibility, 1, 3. And the total number of possible outcomes are 36. So it is just 1 upon
36.
36. Okay.
Yes, ma'am.
Yes, ma'am.
Ma'am, for 1 by 6, I'll support it like we can use conditional probability for this. Probability of the intersection of both the events.
What are the 2 events here?
That one of the die lies on number 1, and the probability that the sum of 2 numbers will be 4.
Okay.
Then the probability.
Sorry, this should be ulta. So first should be sum 4 and number should be 1. So there should be probability that sum is 4, intersection, one of the number is, the first die lands on 1, divided by probability that
First
one lies on 1.
lies on 1.
So what is the numerator over here? What is the probability that one number lands on, the first die lands on 1 and the sum is 4?
1 by 36.
1 by 36.
Or it can be the second die also, no? One of the die.
Ma'am, it can be 2 by 36. Like,
It should be 2 by 36, ma'am.
Okay.
yeah.
And what should be in the denominator?
It should be 6 by 36. It should be 2 by 6, ma'am.
2 by 6. How is this 2?
6 by 36.
See, you were given that one of the die lands on number 1. Or sorry, I wrote one of the die, no? The first, I meant the first one, okay? First die.
Then the answer completely changes.
Okay. Oh, what should be the answer?
1 by 36 divided by 6 by 36.
By 36 divided by
6 by 36.
36. One by 6.
It comes out to be 1 by 6.
But why answer is not simply 1 by 36?
Because see, what is 1 by 36? When you say 1 by 36, this is not the probability that given the first die landed on number 1 and the sum is 4. What 1 by 36 is that one of the die lands on the first die lands on number 1 and the sum of the number is 4. This is intersection, right? This so let's define these two events. So define event E to be first event E to be first die results in 1 and define the event F to be sum of two numbers is 4. Okay. So when I say probability E, what you have to find is probability F given E, right? And what you are finding is this 1 by 36 is what? This is F intersection E. So when you say F intersection E, it means you are saying probability that the first die results in 1. So first die results in 1. This is and the sum of the two numbers is 4. So when you write all the like 66 samples, so let's just write it over here. Maybe it will give you some idea. So 1 1, you have 1 2, 1 3, 1 4, 1 5, 1 6. Yeah, I'll just skip this. Then you have 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. Okay. So okay. So first die results in 1. So that is just the first row. Correct? And along with it, you want the sum of the two numbers should be 4. So that observation is just 1 by 1 comma 3, right? So you want to find the probability of occurrence of 1 comma 3, and this probability is 1 upon 36, because this is just one number and there are total of 36 outcomes. So that turns out to be 1 by 36. But what is asked from you is, given that the first die results in 1. So first die results in 1. So you're restricting your sample space. So before, instead of looking at 36 numbers, 36 observations, now you are going to look at only 6 observations. You're restricting your sample space, right? And from there, you need to find that what is the probability that sum of the two number is 4. So once I've restricted 36 to 6, now I can see that only one observation out of 6 is satisfying this criteria. So this gives me 1 upon 6. And if you use the formula, this is probability F intersection E divided by probability of E. And we found probability of F intersection E to be 1 upon 36. And probability of E, that is first die, results in 1 is, there are 6 such outcomes. So 6 divided by 36, right? And this gives you 1 by 6. I hope it is clear now.
Yeah, ma'am, it's clear.
Yeah, ma'am.
So be careful.
Ma'am, previously you have written.
Hmm? Previously, I had.
Previously you have written one of the die. Then what should be the answer if
In that
that
case,
was there?
okay, one of the die. So we are not saying anything about whether the first die or the second die. So when we are saying one of the die results in 1, so you know that either it can be these, I mean the numbers in the first row. So it can be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, or it can be this column also, right? It is also possible. And this column is what? This column is 2, 1, 2, 2, sorry, 3, 1, 4, 1, 5, 1, 6, 1, right? So if let's say if that was the case, that any one number you have seen that it resulted in 1. So and okay, so now you're restricting your sample space from 36 to 6 plus 5, 11, right? And now out of 11, how many cases you can see that some of the two numbers is going to be 4? It's just 2. Either it can be 3, 1, or it can be 1, 3. So 2 by 11.
Okay, ma'am.
Yeah.
Ma'am, excuse me.
Hmm?
Ma'am, but in which case the answer will be 1 by 36?
Answer is when I'm saying first die results in a 1. When I'm fixing that on the first die, you are getting a 1. Or in the second die, you are getting a 1. Right?
Ma'am, I have a doubt, ma'am.
Okay, tell me.
Ma'am, for the F intersection E, it won't be 2 by 36. Can you explain it, ma'am?
It is 1 by 36, no? What are you are saying? It should be 2 by 36. Hello?
Yeah, ma'am.
You are saying is that probability F intersection E should be 2 by 36. Is it?
Yes, ma'am.
Okay. First you tell me, why do you think it should be 2 by 36?
Ma'am, because like there are two possibilities for 1, 3 and 3, 1. So
No, you're talking about the second question or the first question that we saw?
okay, ma'am, I got that point, ma'am, because it's the first die results in the one. Ma'am, sorry, I got that point.
You got it?
Yeah, ma'am.
Like if you do it in this way, then yes, it is 2 by 36 divided by first that results in 1, that is 11 by 36. So you get 2 by 11, right? You got it, no? How we got 2 by 11?
Yeah, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. All right, let's move further. Okay. So after conditional probability, we have multiplication rule. So let's see. We had defined two events, and if we are saying probability E given F, so this is nothing but probability E intersection F divided by probability of F. We saw this formula. Now, what multiplication rule says is probability of E intersection F is nothing but probability E given F times probability of F. So you just take this on the left hand side, probability of F on the left hand side, and you will get this result. You see, this is nothing but the term on the left hand side. This is nothing but joint probability, right? This term is conditional term. This is conditional probability. And probability of F is marginal. This is marginal probability. Right. So what we are saying is you can write joint probability as a product of conditional times marginal. And this expression over here is called the multiplication rule. So probability E intersection F is nothing but probability E given F times probability of F. So let's do one example. So suppose in a class you have 50 students. Out of 50 students, let's say 20 are boys and 30 are girls. Now from these 20 students, from these 50 students, you are selecting 2 students. Select 2 students. And how are these students selected? So the way we are selecting is, let's say we select one student, and so let's say this is 50 student, okay? And from there, we selected one student. So let's say this is a selection B. You put this one student here. So now you are left with how many small students? 49. Now you're left with 49 students. Now out of these 49, you select one more student plus 1. So this becomes 2. Okay. So this is how the selection has been done. And what kind of selection is this? So you must have heard the names, right? Selection with replacement, selection without replacement. So what does this come under? The way we have selected the students? Does this come under?
Without replacement.
Without
Without
replacement. Because
replacement.
we are picking one student. We are not putting the student back into the class. Now we are another student when we have to pick. We are picking that student from the remaining set of students. Okay. So find the probability that the first student selected is female and the second student is a male. First student is female and second student is a male. Any answers? Anyone?
1 by 15 to 49.
1 by? Can you
T 49.
sorry, I couldn't hear properly. 1 by?
50.
1 by 50?
Into 1 by 4.
Okay. Any other answers?
Ma'am, is it 1 by 30 into 1 by 20?
Okay. 1 by 30 into 1 by 20. Think about it a little. Maybe I'll give you 2 minutes. Think about it and then tell me.
Ma'am, 30 by 50 into 20 by 49.
Okay. 30 by 50 into
20 by 49.
okay.
Yes, ma'am, it is 30 by 50 into 20 by 49.
Okay. The 2 answers for this. Anybody else has any other answers? Any other answers or is this the final one?
Ma'am,
Yes.
it can be 1 by 30 into 5 by 98.
1 by 30 into
5 by 98.
okay. Okay, I want to ask first. Tell me why the first option is right. Whoever has answered 1 by 15 to 1 by 49. Only which one do you think is the right answer? You have 4 options here.
Ma'am, the third one.
The third one. How many of you says the third one is the right answer?
Ma'am, third one, but fourth one is just
Fourth one can also be right.
yes, ma'am. It can be.
Okay. Why do you think both the options can be right?
Ma'am, fourth one I have solved by I take first probability that it is restricted the data and then total probability, and then I took second probability that 1 by 49 by 20 by 50, and then when I solved it, then it will become 5 by 98. That's why I was thinking that it can be right.
No, I didn't understand what you said. Hold on. Okay. So here, just tell it. So option 3 is the right answer. See, the question was asking, you need to find the probability that the first student is a female and the second student is a male, right? So let's define the event that first student is a female as E, and define the event that the second student is a male as F. Okay. So you have to find what is the probability of E intersection F. All right. So probability of E intersection F is what? We just saw it is E given F times probability of F. So probability E given F times probability of F. Right. Now what is probability of F? So probability of F means probability that the second student is a male. If the second student is a male, then see this in the second sampling. I mean, when you're picking the second student, you know total number of students are 49, right? And out of 49, how many are male? 20. So it should be 20 by 49. And what is the probability that given that given that the second student is a male, the first student is a female? I think it is a little confusing. Maybe let's not go through the formula. I'll just simply write it, why the third option is right. So see, you need to find first student is a female and second student is a male. So what is the probability that first student is a female? It is, if you're picking the first student, so that is from total of 50 students. And out of those 50 students, 30 are girls. So instead of, okay, that's female, this is male, okay? So this is going to be 20 by 50. Sorry, 30 by 50. And now when you have to pick the second student, the second student, you have already taken one student out. So out of those 49 students, 20 are male. So this should be the right answer.
Ma'am, using the formula, how do we find P of E by F? In the formula, probability of E when F is already given. Yeah. This one, how do we find it manually?
This you can do E intersection F by probability of F, right? This you can do.
No, ma'am, but in the multiplication rule formula, to find the joint probability, we should first know the conditional probability. But to find the conditional probability, we should first know the joint probability. So which one, how do we approach this thing?
Okay. E intersection.
It's like a continuous formula, ma'am. If we are trying to find E intersection.
The formula, right? Yeah. Okay. So we needed to find E intersection
Like
F.
in this case, we have to find any intersection F. For that, we already need to know P of E by F. But that can be found out using the previous formula.
Yeah. So this is, you can write F given F times probability of M.
Yes, fine.
Now, what is the probability? What is, sorry, not M. We have to note E and F, no? E, and this is also E. So E is, the first student is a female, right? And the first student is a female. That is quite simple. It is just 30 by 50. Fine. Now, F
Yes.
intersection E, it says, given that you know the first student is a female, so first student is a female, F, let's write it as F1. A first student is a female. What is the probability that second student is a male?
Okay, so 20 by 49.
Sorry?
20 by 49.
20 by 49. Okay, next. So you can generalize this. So the general multiplication rule, generalized multiplication rule. What does it say is, if you have events E1, E2, E3, and so on. So let's say you have n events. So this will be given by probability of E1 times probability of E2 given E1 times probability of E3 given E1 intersection E2, so on till probability of En given E1 intersection up to En minus 1. So this is the generalized multiplication rule. There is one example that is done in the lecture. This is from cards, deck of cards. Maybe you can just have a look. Just go through this example once. Okay, so next what we have is independence of events. So when do we call an event is, two events are independent?
When the occurrence of one doesn't affect the other.
Yes. So when the occurrence of one event does not affect the occurrence of other event, we call the two events to be independent. So to check that, so basically what you want to check is we say two events, let's say A and B, are independent if probability of A intersection B is probability of A times probability of B. So this is the definition for the two events to be independent. And when the events are not independent, we call them as dependent events. How did we get this formula? See, before from multiplication rule, we knew that probability of A given B, or A intersection B, is probability of A given B times probability of B. Now, if A and B are independent, I mean, when you are saying the two events are independent, it means that whether the event B has occurred or not, it is not going to affect the probability of occurrence of A. So probability of A given B is nothing but probability of A, right? This is the reasoning you can give for that. So it's if and only if. So it is both ways. I mean, if you are given that the two events are independent, you can say that this happens, or if you know that this is the situation, then they should be independent. Yeah, both ways you can say. Okay, let's do one example. So let's take the example of rolling a pair of die, rolling a die twice. Okay. Define some events. Let's say I'm defining my event E as first outcome is a 1, F as sum of the outcomes is plus 4, right? Let's define another event G as sum of the outcomes is 7. Okay, can you check first? Is E and F independent? Second, is E and G independent? And the third, okay, 2 is okay, I guess. Yeah, just two questions. Can you try it? I'll give you 2 minutes. Just think about this question and try it out. I will ask you in 2 minutes. Okay, what is the answer for the first question? Is E and F independent? Anyone? No, nobody solved the question. I gave you 4 minutes to solve. Yes.
No, ma'am, they're not independent.
Both of them are not independent?
Yes, ma'am.
Yes, ma'am, both of them are not independent.
Okay. So let's see why they are not independent. So first of all, you need to check for the first question, probability of E is F and F and E and F independent. You need to see if probability of E intersection F is probability of E times probability of F, right? So find probability of E. What is probability of E? Probability of E means probability that the first outcome is a 1, right? And this is 6/36 and this is 1/6. Okay. What is probability of F? It is sum of the outcomes is 4. And how many cases you get sum of outcomes to be 4? It can be either 1, 3. It can be either 2, 2.
2,
It can be either 3, 1.
3, 1.
It can be either anything else. No, right? These 3 are the only possibilities. So you have 3 divided by 36, which is, or let's leave everything in 36 only. It's easier to check. Now, if you want to find probability of E intersection F, this is not in E intersection F, right? So E intersection F means first outcome is a 1 and the sum of the outcome is a 4. So we had found this probability to be 6/36 or basically 1/6, right? So you can easily see that this 1/6 is not equal to 6/36 times 2/36. So yes, they are not independent. Now what about E and G? So now you need to just find probability of G. What is probability of G? Sum of the outcome is 7. So how many cases you can have? You can have 1, 6. You can have 2, 5. You can have 3, 4. You can have 4, 3. You can have 5, 2. You can have 6, 1. So total of 6 cases. So probability of G is again 6/36. And probability of E was 6/36. Now what about probability of E intersection G? So E intersection G is first outcome is a 1 and the sum of the outcome is 7. So this is possible only for 1, 6. So this is again 1/6. So again you can see that 1/6 is not equal to 6/36 times 6/36. So again E and G are not independent. So hope this is clear to everyone. Any doubts?
Yes, ma'am. No, ma'am.
Okay.
No, ma'am.
All right. So after independence, you have something called law of total probability. Okay, before this, we also have one proposition. It says if E and F are events, okay? So if events E and F are independent, then E and F complement are also independent. We'll see this from a Venn diagram. So start to circle. Okay. Okay. Let's say these are the two events we have. This was bad. Okay, let me just start this. All right. So we have, let's say, two events, E and F. Now, what we need to show is, like, if you have events E and F to be independent, then you need to prove that E and F complement are also independent. So to show E and F complement are independent, what do you need to check? You need to check that probability E intersection F complement is nothing but probability of E times probability of F complement, right? So you are assuming that E and F are independent. So event E, you can write it as E intersection F union of E intersection of F complement. Is this okay? Is this okay? Why we are writing event E as E intersection F union E intersection F complement? Anyone? Is it clear? Not clear? No one? Okay. So I will assume you understood. So see, we can write event E as E intersection F times E intersection F complement. Now, you know that, I mean, you can easily see that these two events, I mean, they are mutually exclusive. So basically, where this represent E intersection F, this represents E intersection F complement, right? And you can see that they are disjoint, they are mutually exclusive. So we can add, if we have to find the probability of E, we can add their probabilities. We can write probability of E intersection F plus probability of E intersection F complement. Okay. Now E and F are independent. We are assuming that E and F are independent. So if E and F are independent, what we can write is probability of E is probability of E times probability of F, right? Plus probability of E intersection F complement. Okay. So now you can take probability of E on the left hand side and you will get probability of E times 1 minus probability of F equal probability of E intersection F complement, right? And probability and 1 minus probability of F is nothing but probability of F complement, right? And this we get as E intersection F complement. So what we got is, we got probability of E intersection F complement as probability of E times probability of F complement. It means that E and F, if E and F complement are independent, right? Any doubt?
No, ma'am.
Okay. So this was about probability, independence of two events. But if you have to check independence of three events, now let's say you have events E, F, and G, and you want to check whether E, F, and G are independent or not. Okay, so to check this, you need to, so the first thing would be, you need to check that probability of E intersection F intersection G equal probability of E times probability of F times probability of G. The second should be, they all should be independent to each other. I mean, E should be independent to F, F should be independent to G, and G should be independent to E also. So you also need to check that they are that E intersection F is probability of E times probability of F. Probability F intersection G is probability F times probability of G, and probability E intersection G is probability of E times probability of G. Okay, so you need to check all these four to check the independence of the three events E, F, and G. So now we have just the last topic left with us, that is Bayes theorem. Let's do this. Just give me a minute. I'll be back. Okay. Does anyone wants to tell what is Bayes theorem? Anyone? Do you know what is Bayes theorem? Law of total probability. Okay, yeah, law of total probability is left. So before this, let's see law of total probability. So what does law of total probability says is, okay, Banu statement multiplied by the probability of the first statement. Okay, thanks Banu for the definition. Okay, so what does law of total probability says is, suppose you have a set of events F1, F2 up to F say Fk. Okay, and these events are such that they are mutually exclusive to each other. So when we say they're mutually exclusive, it means F1 intersection F2 intersection up to Fk should be phi, and they are exhaustive. It means that their union, I mean, if you take their union, I mean, the sum should be the whole sample space, basically. Not sum, union. Union of Fi, I varying from 1 to k, should be the whole sample space. Okay. So this is what we meant by mutually exclusive and exhaustive event. So this will look more like, let's say you have, I can draw it like this. So suppose this is your event F1, this is your event F2, this is your event F3, so on. This is your event Fk. Okay. And now let's say some event E has occurred. So some event E has occurred. Let's say this is my event E. All right. So now if you have to find what is probability of E, then this is nothing but, you can look at the figure and tell that this is nothing but probability that E intersection F1 plus probability E intersection F2 plus up to E intersection Fk, because they are a mutually exclusive event, right? And this whole sum can be written as sum over probability E intersection Fk, not k, let's write as I. So I varying from 1 to k, and you know from the multiplication rule of probability that this should be equal to I from 1 to k probability E given Fi times probability of Fi. Okay. So what we are saying is, if we have a collection of events F1, F1, F2 up to Fk, such that they are mutually exclusive and exhaustive, then probability of E is nothing but sum over probability of E given Fi times probability of Fi, where I varying from 1 to k. And Bayes theorem is just the extension to this. Bayes theorem is more like the conditional probability. So what does Bayes theorem says is, so given the events that they are mutually F1, F2 up to Fk that are mutually exclusive and exhaustive, Bayes theorem says that for any event E, if I want to know what is the probability that given the event E, probability of any Fi is probability that E intersection Fi divided by probability of E. And from law of total probability, you know that probability of E is nothing but, so this is probability of E intersection Fi. This is divided by probability of E intersection Fi times probability of Fi, I varying from 1 to k. And the numerator term, you can use the multiplication rule, and this can be written as probability Fi given E as probability of E given Fi times probability of Fi divided by sum over I varying from 1 to k probability of E given Fi times probability of Fi. So this is what the Bayes theorem is. Okay. Let's do one example to understand this law of total probability and Bayes theorem. Okay, I'll take the same example. Okay. Or let's say, okay, suppose you have a manufacturing company, and let's say the company produces bolts of 3 types. Okay, let's say bolts from like 3 different machines. Okay, so machine A, machine B, machine C. So what we are saying is, it is given to us that given that okay, each of these machine A, machine B, and machine C, the probability that they make the defective screws is, let's write it as probability of the screw being defective that is made by machine A is, let's say 0.02. Machine B, let's say the probability that it makes a defective screw is 0.01, and let's say this is 0.03. Okay, now let's say you select one bolt from here. Select one bolt. So select one bolt that is produced from either machine A or machine B or machine C. So suppose what you see is this bolt is defective. You selected one bolt and you found it that it is defective. So now the question is, what is the probability that it is coming from machine A? Is coming from machine A, given that, okay, what is the problem that is coming from machine A, and this selecting one bolt is equally likely. Okay, just mention one more thing here. Equally likely. Equally likely here, what it means is, like the bolt that you are selecting, either it can come from machine A, or it can come from machine B, or it can come from machine C, with the probability 1/3. Okay, so how can you write this? So the information that is given to you is, first of all, what do you have to find? You have to find probability of the bolt being defective, given that it is coming from machine A, right? So this, what can this be written as? This can be written as probability that the bolt is defective. Intersection, it is coming from machine A, divided by probability. Sorry, I've written opposite. So the question was, given it is defective, what is the probability that is coming from machine A? So this is probability of defective bulb. This is the setup we have. Okay. Any doubt here? Any doubt in whatever I have written? No? Okay. So can you find me this probability? Can you tell me what the numerator is going to be? What is the probability that the bolt is defective and coming from machine A?
0.02.
0.02.
Okay. And what is the denominator going to be?
0.06.
0.06. Okay. Anyone else?
Yes, ma'am. 1/3.
1/3. See, first you need to find what is the probability of the bolt being defective. So we have selected one bolt and we need to find what is the probability that a bolt is defective. So this is what? This is probability. Let's write it as D, probability of D. Let's note as this. So probability of D, given that it can come from machine A times probability of A plus probability of D given B times probability of B plus probability of D given C times probability of C. Right? This is the probability of any bolt being defective. See, we don't know like from where this defective bulb is coming, right? Bolt is coming. Either it can come from either this bolt are being produced from factory 1 or this bolt is being produced from factory 2, machine B, or it is produced from machine C. So if it is produced from machine A, then you need to add the probabilities for all the three, right? So D given A, defective given that it is coming from A is 0.02. And this probability of A, as I said, since it is equally likely, so 1/3 plus 0.01 times 1/3 plus 0.03 times 1/3, right? This is just probability of a bulb being defective, bolt being defective. Now probability that, look at the numerator term. Now it says find the probability that the bolt is defective and coming from machine A. So this is nothing but, this is probability that D given A times probability of A, which will turn out to be, so this is 0.02 times 1/3 divided by 0.02 times 1/3 plus 0.01 times 1/3 plus 0.03 times 1/3. Okay, it does turn out to be same. Okay. Yeah. So since 1/3 is common, so you can just do 0.06. Oh. So this is how you should do it. See here, since I said that they're equally likely, you ignore this 1/3. But in case these probabilities were different, I mean, if probability of A, probability of B, probability of C were something else, then in that case, the answer would have been varied. Okay, so just be careful. Like here, many of you said directly that it is this, but you had not divided by 1/3, right? Multiplied and but when they were not equally likely, then in that case you need to be very careful when you're solving it. You need to do this process that I just did. Okay. So I hope that is clear. Any question?
Yes, ma'am.
Okay, there are no question and we're almost done. So these are the topics that we had in week 8. If you have no question, we can close the session. If you have some question, you can go ahead. And also, I just wanted to make an announcement for the extra activity. So the extra activity, as you said, the IITM study.iitm domain is not given to you. But for now, please do the activity. And later, we'll announce you like how do you have to submit it. Okay. So please do not delay. You do your work from your side, and we'll let you know if there are whatever the further procedures are.
Ma'am, for those with the IITM domain, like, should they do and submit it?
Do you have the IITM domain?
Yes, ma'am.
How do you have it?
With that, do you mean IITM email ID?
Yeah, IITM email ID is study.iitm.ac.in.
Yeah, I'm a JEE student, so I got it on the first day itself.
Oh, okay. Okay, maybe you can submit it if you have it. For the people who do not have the ID, maybe you can just do the activities, and for regarding the submission, we'll let you know. Okay.
Ma'am, can you please
Yes, ma'am.
extend the due date of a weekly extra activity?
Yeah, we'll do it. Let's see. We'll send you an announcement.
Okay, ma'am.
Okay.
Okay.
All right then. If you have no doubts, we can close the session.
Okay, ma'am.
Yeah. Okay.
Good night, ma'am.
Thank you all. Thank you for joining.
I have one question.
Yeah.
Graded assignment, question number 6.
Graded assignment question number 6. No, like okay. When you do solve with us, right? So there, solve with us, you will have you get questions which are very similar to graded assignment. So maybe you can ask.
Okay, ma'am.
Yeah.
Okay.
Ma'am, I have doubt regarding the extra activity. So, will we get the marks based on the practical activities or the extra activity?
These bonus, they are the bonus marks. I mean, this is apart from what assignments you do or what marks you get on the basis of assignment. But this is something which is bonus, that is separate 10 marks. So if you do those and you do well, depending on whatever the criteria were set for you, then on that basis you get a bonus of 10 marks.
Yes, ma'am. But in other subjects, like if you do the practice activity,
This
the
is
practice
different.
assignment, so
This is
you
different.
get marks.
This is different.
So it is on top of that.
Yeah.
Okay, ma'am.
Okay.
Thank you, ma'am.
Thank you. Thank you all
Thank
for
you, ma'am.
joining. Have a good day. Bye.
Thank you, ma'am. Good night, ma'am.